Question 20. On another planet, a ball is launched vertically into the air from the ground. The height above the ground, h meters, can be modelled using the function h equals -6t squared plus 24t, where t is measured in seconds. The graph of the function is shown. Part A. Based on the graph, what is the maximum height reached by the ball? Let's analyse this graph. Firstly, it's a concave down parabola. We know this because the highest power of the independent variable t is a 2. Secondly, the t squared term is being multiplied by a negative number, -6, and that's what causes the graph to be concave down. Now the vertex, or the turning point of this parabola, represents the maximum height that the ball will reach. Now we can work out the maximum height of the ball in one of two ways. The first way is by inspection, locating the vertex and then projecting across to the y-axis, which represents the height of the ball at any particular time, and then reading the height directly on the y-axis, or the h-axis in this case. So locating the vertex and projecting across, this is the maximum height of the ball here, which is 24 meters. And we can count from 20 or count down from 25, 20, 21, 22, 23, 24 meters. So that's the maximum height that the ball will reach. The other way we can work this out is algebraically. We know that the maximum height of the ball is reached at time t equals 2 seconds, which is exactly halfway between when the ball is launched into the air at time t equals 0 and when the ball lands on the ground at time t equals 4. So the point halfway between 0 and 4, which is the average of 0 and 4, which is 2, substituting 2 into this equation for t and then evaluating -6 times 2 squared plus 24 times 2, we get 24 meters. And the answer is written here. Part B. Based on the graph, at what 2 times is the ball at 3/4 of its maximum height? The first thing we need to work out here is what is 3/4 of the maximum height that the ball will reach. Now, from part A, we worked out that the maximum height is 24 meters. So 3/4 of 24 meters, so that's 3/4 times 24 meters, is equal to 18 meters. So going back to the graph, locate 18 meters on the y-axis or the vertical axis. If we project across until we strike the parabola in these 2 points here, so at this point here and at this point here, and then project directly downward to read the time directly off the x-axis or the horizontal axis, at the first point or at the first time that the ball reaches 18 meters occurs at time 1 second after the ball is launched. And the second time that the ball reaches a height of 18 meters, so that's on the return, is at time 3 seconds after the ball is launched. So writing that down as our answer, the ball reaches a height of 18 meters at time 1 second and 3 seconds.